Bismillahirrahmanirrahim. Welcome to the world of physics. It's me, Sabah Sayed, and I'm here to teach you the branches of physics. Here's the table of content. Physics, basic branches of physics, classical physics, modern physics. In physics, we will discuss the definition of physics, and in classical physics, I will describe the classical physics and modern physics, and at the end, I will discuss the difference between classical physics and modern physics. Basically, the definition of physics by Oxford English Dictionary is the branch of science concerned with the nature and properties of matter and energy. The subject matter of physics includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structures of atom. And the classical physics, this branch of physics is mainly concerned with the laws of motion and gravitation as outlined in Sir Isaac Newton and James Clerk Maxwell's kinetic theory and thermodynamics respectively. This branch of physics deals mostly with matters and energy. Often physics which date before 1900 are considered as classical physics, while the after 1900 date after 1900 will considered as modern physics. While in classical physics, energy and matter are considered as separate entities, acoustics, optics, classical mechanics, and electromagnetics are traditionally branches within classical physics. Moreover, any theory of physics that is considered null or void in modern physics automatically falls under the realm of classical physics. At Newton's law are one of the most feature of the classical physics. Let's examine them. What are the three laws of physics that are also known as Newton's laws? The three laws of physics, they are commonly referred to, are also known as formally as Newton's law of motion. They are considered the basic of classical mechanics. Newton's law describes the motion of a body upon which forces may act and which may exert forces on the other bodies. When we speak of bodies, we are not speaking of actually human bodies. All the human bodies can be included in this definition, but any piece of matter upon which a force may act. Newton's three laws are outlined below. Newton's law of motion are the first law of motion is also known as law of inertia, which is stated that a body remains at rest or in uniform motion in a straight line unless acted upon by a force. The second law of motion, F is equal to ma, also known as F is equal to force is equal to mass by acceleration. A body's rate of change of momentum is proportional to the force causing it. And the third law of Newton's third law is third law of motion. It could also be said as Newton's third law of motion is action to reaction is equal to reaction force. Action is equal to reaction law. When a force acts on a body due to another body, then an equal and opposite forces act simultaneously on that body. And here we will discuss the modern physics. Modern physics, the branch of physics that is mainly concerned with the theory of relativity and quantum mechanics. Albert Einstein and Max Planck were the pioneer of the modern physics as the first scientists to introduce the theory of relativity and quantum mechanics respectively. In modern physics, energy and matter are not considered as separate entities. Rather, they are considered different from each other. And what are the two main pillars of modern physics? The two pillars of modern physics are Albert Einstein's theory of relativity and Max Planck's quantum theory. What is theory of relativity? Albert Einstein's theory of relativity is one of the most important discoveries of the contemporary age and states that the laws of physics are the same for all non-accelerating observers. As a result of this discovery, Einstein was able to confirm that space and time are interwoven in a single quantum known as space-time. As such, events that occur at the same time for one observer could occur at different times for another. Einstein's theory of relativity is summarized in the formula E is equal to mc square. In this equation, E represents energy, m represents mass, and c represents the speed of light. What is quantum theory? Discovered by Max Planck in 1900, quantum theory is the theoretical basis of modern physics that explains the nature and behavior of matter and energy on the atomic and subatomic level. The nature and behavior of matter and energy at that level is sometimes referred to as quantum physics and quantum mechanics. Planck discovered that energy exists in individual units in the same way that matter does, rather than just as a constant electromagnetic wave. Thus, energy was quantifiable. The existence of these units called quanta act as the basis of Planck's quantum theory. Here is the difference between classical physics and the modern physics. As we know, the classical physics is based on Sir Isaac Newton and James Clerk Maxwell's kinetic theory and thermodynamics, respectively, while modern physics is based on Albert Einstein's theory of relativity and Max Planck's quantum theory. In classical physics, gravity depends on mass and the inverse square law, while in modern physics, gravity depends on mass, momentum, and energy. Entropy and enthalpy are not measured or recognized in classical physics, while entropy and enthalpy are important in modern physics. Quantities of space, time, mass, and energy are continuous in classical physics, while quantities of space, time, mass, and energy are discrete and quantized in modern physics. Time is absolute, rigid, and universal, and in classical physics, while time is relative and local in modern physics. Or in other words, we can say that in classical physics we will discuss, or we will read, or we will learn about, or we will research on the things that was greater in mass or greater objects. And while in classical physics we will study about thermodynamics, electrodynamics, theory about gravity, while in modern physics we will discuss about the small objects like photons, quarks, leptons, electrons, and all these things. Thanks for watching.